Cracking the TOEFL. Track 1. Listen to a biology professor give a talk on an environmental issue.
There's been a lot of talk over the last few decades about greenhouse gases. Those gases in the atmosphere that trap radiation from the sun so that after it passes into the atmosphere, it doesn't pass out. People are increasingly conscious of the environmental effects of their daily activities, which is a good thing. But all the publicity can be confusing, too. I think writing for the general public about science is a real service, but, well, it's not nice to say, but I wish some of these people would verify things with real scientists more often. They'd save themselves some embarrassment. With that in mind, I'd like to clear up some things about that hot topic, carbon dioxide. Carbon dioxide is a greenhouse gas. It absorbs energy from the sun. In that respect, it's like water vapor and methane, two other naturally occurring greenhouse gases. You all know that carbon dioxide is produced when we burn fossil fuels, coal, petroleum products, natural gas, and that those fuels run a lot of the machines and manufacturing processes that drive modern life. Those are the sources that get all the public attention. But of course, we produce carbon dioxide as a waste product too. It's one of the byproducts of respiration. We breathe in air, use up some of the oxygen, and breathe out air that contains carbon dioxide. So do other animals. Because carbon dioxide is part of the natural life cycle, nature has a way of dealing with it. How does nature control the amount of carbon dioxide floating around in the atmosphere?
I thought the ocean soaked it up.
Yes, that's one way. Carbon dioxide is very soluble in water. Soluble. I don't have to explain that one to you, because the root's related to the word dissolve, right? So, carbon dioxide is pulled readily out of the air and into the water. Now, the oceans also release some of their carbon dioxide, but on balance, they absorb more. So that means that if we produce artificially more than would naturally be emitted through life processes, the ocean could, as Jason put it, soak it up. Unfortunately, if we're looking for a solution to carbon dioxide pollution, the ocean isn't it. And that's because the ocean absorbs gases from the atmosphere very, very slowly. If we suddenly increase the amount of carbon dioxide we produced, current models suggest that it would take 1,000 years for it to mix into seawater. And even then, there would still be a small amount left. So, over the short and medium term, we can't rely on the ocean to take up the slack for us. Okay, so that's one way nature deals with carbon dioxide. What's the other?
Plants, isn't it? I mean, plants breathe carbon dioxide the way we breathe air.
Sure. I was actually kind of surprised that wasn't the one mentioned first. Yes, plants require carbon dioxide for photosynthesis. The more dense the growth of large plants, the more carbon dioxide is absorbed. Such an area, including forests of large, old-growth trees and also the ocean, where carbon dioxide is absorbed in large quantities, is called a carbon sink. The carbon dioxide gas is sucked in, kind of the way water is sucked down the drain in your sink after you wash the dishes. In fact, in the ocean, there are algae, seaweed, other kinds of marine plants too that rely on carbon dioxide to perform photosynthesis, just like the green plants on land. It's just that algae are far, far smaller. Now, here's something interesting. Like the ocean, green plants release carbon dioxide into the atmosphere as well as absorb it. When a plant dies, if it burns in a forest fire or just dies of old age and decays, then its carbon dioxide is back in the air. So it only holds it in over its lifetime. However, this is the interesting part. Unlike the ocean, green plants soak up carbon dioxide to use it, to make the energy they need to live and grow. So, what they've found in some regions, populated, industrialized regions, is that increased levels of carbon dioxide can stimulate plant growth. There's more of the fuel the plants need for energy, so they grow more green and dense and lush and use more of it. In other words, the amount of carbon dioxide used up by plants can increase quickly in response to the environment. Some people have suggested that we can use that natural phenomenon to help deal with increased levels of greenhouse gases in the atmosphere.
What is the discussion mainly about? What is the problem with relying on the oceans to solve the problem of excess amounts of carbon dioxide? What did the professor call areas where carbon dioxide is absorbed in large quantities? Listen again to part of the discussion, then answer the question.
I think writing for the general public about science is a real service, but, well, it's not nice to say, but I wish some of these people would verify things with real scientists more often. They'd save themselves some embarrassment.
What did the professor mean by this?
I wish some of these people would verify things with real scientists more often. They'd save themselves some embarrassment.
Listen again to part of the discussion, then answer the question.
Soluble. I don't have to explain that one to you, because the root's related to the word dissolve, right?
What did the professor imply? How are plants different from the oceans in the way they absorb carbon dioxide? Click on two answers.